I would like to start out today by thanking all of you who are taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the Fischer-Technic Education Division over here at Studica. And of course, today I'm going to provide you with an overview of Fischer-Technic's line of pre-assembled industrial simulation and training models, including the very latest models incorporating new cutting-edge technologies. So basically, over the years, I would typically begin these types of presentations with a discussion of the importance of STEM education and talk about changes in the manufacturing environment, as well as the growing need for highly skilled workers in the modern workforce. But at this point, I really think it's fairly well established just why technology-focused education is necessary. So with that being said, I'm going to dispense with any preamble and pretty much jump right into the discussion of what Fischer Technic is, and then I'm going to show you each of the current models in the simulation family. Now, Fischer Technic simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line we're going to look at consists of a series of pre-assembled small-scale models which are essentially designed to replicate, in both appearance and in function, various automated robotic machines and systems that are commonly used and found in commercial manufacturing processes. Now, before we begin to look at each of these models, I'm just going to provide you with a little bit of background on what Fischer Technic is. Fischer Technic has been creating tools for teaching students of all ages how technology works for well over 50 years now. Actually, it will be 60 years later this year. And it's all based around their unique building system, which you see on the screen right now. What makes this system unique is that unlike other popular construction systems where the parts are designed primarily to stack, the Fischer Technic system was created with more of an engineering mindset. Now, the core building block that you see on the screen right now is designed to enable attachment from all six of the sides, and because of this, it allows for almost limitless design possibilities. And in addition to this, they use very specialized pieces that will also help any sorts of technical builders to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who's shown on the screen right now, and he's noted for countless innovations used in both the construction and the automotive industries. Now, Mr. Fischer, at the time of his death, which was in 2016, he held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, which is a pretty impressive statistic. Now, prior to creating Fischer Technic, Mr. Fischer was first noted as the inventor of synchronized flash photography. This was back in 1949, and a few years later, he gained fame as the creator of the expanding nylon wall plug, which we've all pretty much used. It's commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. Uh, and his company, the Fisher Group, now continues to employ thousands of workers all around the globe, producing many variations of fastening devices that are used in building construction. And they also produce numerous components used in the automobile assembly process, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fischer Technic building sets, and this really doesn't matter whether we're talking about those sets that are designed for the retail market or those that are really designed for classroom use. In either case, the focus has always been on helping to foster an understanding of technology and how things work. Now, many of the products offered by Fischer Technic specifically for the education sector are what we refer to sometimes as subject-specific sets. They focus on different STEM-related topic areas, things like mechanics, pneumatics, robotics, renewable energy, and so on. Now, many of these sets also include curriculum or detailed teaching and activity materials. And in the case of most of these types of sets, students are going to be asked to build a progression of models using the unique Fischer Technic building system, which allows them to learn different aspects of the topic that they're studying. And then they perform various experiments, which allows them to better explore and understand key sub aspects of that topic. Now, the line of Fischer Technic simulation solutions, which are, of course, what we're going to focus on today, are something much different. This line consists, again, not of kits, but these are going to be pre-assembled small-scale models, which are designed, again, to replicate in appearance and function various automated robotic machines and systems. Now, some of the models in the fischertechnik simulation line will include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high-base warehouse storage systems. Now, besides these individual models, which are designed to focus on specific automated processes, fischertechnik also now offers special or several variations of an integrated factory simulation model. Now, in these factory simulation models, you'll typically have four or more of these individual workstations, most commonly the vacuum gripper robot, a high bay storage warehouse, a multi-processing station with the oven, and a sorting line and color detection. And these four workstations, or more workstations, as you'll see, depending on the model, in each case, they're all working together as one self-contained material cycle. Now, of course, we're going to look at all of these a little bit more in more detail a little later in the presentation. Now, before we get into that, I'm just going to briefly outline some of the advantages of using fischertechnik simulation models. First off, fischertechnik simulation solutions allow educators to offer engaging hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for, let's say, understanding how an automated system works, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate in both appearance and function commonly automated systems, and these are going to be things, again, like conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases no more than tabletop size, they're also not only ideal for use in the classroom or for in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next aspect is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each model that we're going to be looking at is available in a 24-volt version specifically for industrial users, with select models available in 9-volt versions for those who are not versed in or focused on the use of PLCs. The 24-volt versions are designed for use with industry standard PLCs. Now, in most cases, it doesn't matter whether you prefer Allen Bradley controllers, Siemens controllers, or if you prefer controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, of course, many others as well. In most cases, you can control these 24-volt versions with the PLC you prefer. The few exceptions to this are going to be some models which we'll discuss at the very end of the presentation where there are specific PLCs that are included with the model, and of course we'll address that as it comes up. Now, likewise, just as you can use your choice of controller, you can also choose your preferred programming language from the list that you see here. Please note that in the case of most of these 24-volt versions, until I mention otherwise, there's going to be no PLC included. So in the case of most of these models that we're going to be looking at, most of these, let's say these modules or substations, the PLC isn't included, so you will need to provide the PLC, and there is not programming. So in most cases, you'll have to provide the programming. Of course, it's going to depend on which programming language you prefer, but basically that option is going to be left up to you. But of course, this shouldn't be an issue as these models are designed specifically for industrial users or for anyone who's involved in teaching or exploring industrial processes involving PLC programming. Now, as I did touch on, there are also 9-volt versions available on select models. Now, in the case of these 9-volt versions, they will ship pre-wired to fischertechnik's own proprietary robotic controllers, which are the robotics TXT controller. And in the case of these TXT controllers, these are either going to be programmed using fischertechnik's own proprietary language, which is RoboPro coding currently, or in some cases C, C++. Now, in the case of these 9-volt models, the only additional component required would be the addition of one or more 9-volt power supplies, basically a power adapter that you would plug in to power the TXT controllers. Otherwise, in most cases, these 9-volt versions will essentially be ready to use right out of the box. Now, the next thing is if you're involved in demonstrating or exploring IoT, which is, of course, the Internet of Things, besides the fact that many end users have made their own adaptations to some of these models in the primary line of simulation and training solutions to make them work for IoT purposes, Fisher Technic now also offers several variations of IoT-focused models, specifically IoT-focused versions of the factory simulation, which were designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. Now, in the case of these models, the model is designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to get into these details in just a little bit. Finally, Fisher Technic simulation models are extremely cost effective. Now, if you have had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice pretty quickly that the entry point for many of these products can easily be $30,000 to $40,000, and we're talking about the entry point. 30 or $40,000, or even much, much more. Now, Fisher Technic simulation solutions, on the other hand, start off at just a fraction of that price. And again, you couple that with being compact, realistic, high quality learning and demonstration tools, and you'll see that there really is a lot of value here. So, with all of that being set up, let's look at we're going to look at the models which are currently available, and we're basically going to start off with a at some of the more basic modules, and then we're going to work our way up to those larger factory models that I alluded to earlier, which again will normally consist of several of these individual workstations designed to showcase an entire production cycle. So we're going to start off with the classic line of Fisher Technic simulation models. And the first model we'll look at is a basic conveyor belt. And essentially, this is a transport belt with a length of 275 millimeters that is used to transport a workpiece with a diameter of up to 29 millimeters. Multiple conveyors could be easily connected to increase the length of transport if you did so desire. Now, the components on this model will include things like an excess motor, a push-button limit switch, two photo transistors, and two LED light barriers. The dimensions of the model are approximately 14 by 10 by 4 inches. It has a weight of just about 2 pounds, and it's available in both the 24-volt version with a multi-pin connector. It's going to be 26 pins with a 2.54 millimeter grid, as you see here in this photo. And again, the 24-volt version of this model, as well as most of the 24-volt versions we're going to be looking at in this early part of the presentation, will require you to provide the PLC and the programming. Now, there is also a 9-volt version which is connected to a pre-wired robotics TXT controller, as is shown here, and one 120-volt power adapter is required for operation. Now, I will mention that for this and for all of the models that we're going to look at today, the specs for these are also detailed in the product listings found on the fischertechnik.biz website, as well as in our product brochure, which I will provide information on obtaining at the end of the presentation. I see something about a screen being frozen here from one of our attendees. No, our screens are not frozen here. So uh, just to jump in, Christy, are you seeing the screen? Are you seeing the conveyor belt 9-volt right now or no?
Yep, I'm on the conveyor belt.
Okay, so I'm not sure what is happening there with the frozen screen that you might be seeing, sir. Because yeah, we are moving right along here. So if anyone else is having a problem with the frozen screen, I would please ask you to jump in and use either the webinar chat window or the Q&A window, both of which will be found on the Zoom toolbar, because of course we want to know that you're seeing everything you need to. If
Yeah,
there's
just to interject, sometimes if that happens, it's better just to pop off and come back on, and it'll reset it for you.
We're talking about for the attendee, correct?
Correct. Yep.
Yeah. Okay. Just want to make sure we're not.
Not you, Lance, not you.
Okay. I'm staying right here. So, all right. Hopefully, I would say please try that. Please try to sign right back on again. And meanwhile, I'm going to move along to the next model. The next model is the punching machine with a conveyor belt, and this is essentially a variation of the conveyor belt that we just looked at, except in this case, of course, it's got a machining station built onto it. Components that you're going to find in this model include two excess motors, two push-button limit switches, two photo transistors, and two LED light barriers. The dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, it's available in the 24-volt version with a 26-pin connector and a 2.54 millimeter grid, as shown in this photo. And the 9-volt version is wired to the robotics TXT controller, which will again require one power adapter for use. The next model we're looking at is the index line with two machining stations. Now, this model features a U-shaped conveyor line consisting of a milling and a drilling station and four conveyor belt sections. Components on this model include 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches, and it has a weight of about 8 pounds. Again, it's available in a 24-volt version, which has a 26-pin connector with a 2.54 millimeter grid for use with PLCs, and also a 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. And by the way, I will mention why I do note the pin connectors and the grid size when I'm talking about some of these models, because it does change on some of the later models. So just if for anyone who this might be important to, that's why I mention it. The next variation we're going to be looking at is a variation on the idea of a pick and place robot, which is the 3D or three-axis robot. Now, the three-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces, which it picks up into three-dimensional space. The degrees of freedom for the robot are as follows. One axis can turn 180 degrees. Axis 2 can move forward or back 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on this model will include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. Now, as with the other models we've looked at, this is again available in both a 24-volt version with the 26-pin connector and the 2.54 millimeter grid designed for use with the PLC and the programming of your choice, both of which you must provide. So everything we've talked about so far, you need to provide the PLC and the programming. And there is also a 9-volt version, which does come wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. The next model we're looking at is the vacuum gripper robot. And in starting here, we're going to get to see some models in motion. So while this starts off, I'm just going to have a drink here. Now, what you're going to see here is the vacuum gripper, which is a three-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position work pieces in three-dimensional space, but obviously with the vacuum gripper, which makes it different from the previous model we discussed. It includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions are approximately 9 by 19 by 15 inches. It has a weight of about 7 pounds. The 24-volt version of this model, as well as all of the 24-volt models we're going to be looking at moving forward, each have a relay board for motor polarity reversal and both a multi-pin connector. In this case, we're talking about 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the 24-volt version of this model will require you to provide the PLC and the program. In this case, there is unfortunately not a 9-volt version available, so if that was something you need, not with this one, at least in particular. We'll just let this play out for a minute before we move on to the next model. And believe we're all set. So the next thing we're going to look at is the automated high bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots. Components of this model will include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, along with a selection of different colored workpieces and carrier trays for each piece. Now, I will mention that this particular model seems to be a favorite among educators I've spoken with who are involved in teaching programming, specifically PLC programming. And the reason that I've heard is because it provides the students with a lot of very specific programming tasks that they need to address. Things like the precision of the picker arm as it has to remove and store the various workpiece trays and so on. So if you're looking for a programming environment, this is a great model to use specifically for that. Getting back to the model, dimensions of the model are approximately 19 by 28.5 by 15 inches. It has a weight of 18 pounds. The 24-volt version has a relay board for motor polarity reversal and both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you need to provide the PLC and the programming, and there is, at least for the moment, a 9-volt version available, which does ship pre-wired to the pre-programmed robotics TXT controller, requires one power adapter. Next up is the multiprocessing station with oven. And what you're going to see here is a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that will include a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components found on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, it's available in both the 24-volt version for use with the PLC of your choice, with once again a relay board for motor polarity reversal, and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And the 9-volt version in this case is connected to 2 robotics TXT controllers. So in this instance, if you get the 9-volt, you will need 2 power adapters as well along with it. We'll just let this play out for a second here. Again, if anyone does have any questions along the way, please use the webinar chat or the Q&A window, both of which are on the Zoom toolbar. Type them in. If I see them and I can address them during the presentation, I will. If not, I will definitely do so at the end. So they seem quite happy with that, and we'll move along to the sorting line with color detection. And what you're going to see here is a simulation that features a system for detecting workpieces of different colors that sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches. It has a weight of about 10 pounds. As before, the 24-volt version has a relay board for motor polarity reversal and both multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the end user must provide the PLC and the programming. The 9-volt version does come pre-wired to a pre-programmed robotics TXT controller, and again, 1 power adapter is going to be required if you use that. We'll let this play out for just a second here, get the pieces sorted, and we will move on to the next model. All right. So now we're going to begin our look at the factory simulation models. And the first model we're going to look at is the basic factory simulation, which does combine the last four models we reviewed, in this case, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with an oven, and the sorting line with color detection. It combines these four models into essentially one self-contained material cycle. And the cycle that you're going to see in this upcoming video works like this, essentially. You have work pieces that are retrieved from the automated high bay warehouse where they've been stored, and the retrieval is done using the vacuum gripper robot. They then get moved to the multi-processing station with the oven to be worked on there. Now, after the work piece gets processed by that station, it is then sorted by color in the sorting line with color detection before it is again moved back by the vacuum gripper robot to the automated high bay warehouse for storage once again. Now, as we've already discussed the components of each of these models previously, I'm not going to belabor it by restating them here, but what I do want to mention are the dimensions of this model as a whole, as you see it on the table here with the people around it. Again, it combines four individual models into one cycle, and because of this, it has a much larger footprint, which we're looking at essentially about 39 by 31 by 16 inches, and you have a weight of between 43 and 46 pounds, depending on whether we're talking about the 24 volt or the 9 volt version. Now, due to these dimensions, please note that this model is only going to be shipped flat. We always ship it as freight on a pallet. And I do like to point out that these factory simulation models can be in high demand. So if you order one of these during our peak ordering season, which is typically when we're preparing schools for the fall semester and things of this nature, that you may be looking at a little bit of a backup. But usually it's not more than a couple weeks at worst. Right now, if you were to order any of this model or most of the models we're going to be looking at coming up, we should be able to supply those pretty quickly for you, so it shouldn't be a problem. A few other things to note. This one is, I believe, available in both 24 volt and 9 volt version. In the case of the 9 volt version, it would be wired to 5 robotics TXT controllers. And because of that, you would need 3 power supplies with it. I do want to mention that there is a storage option for this particular model, and this would also be used for a couple of the models we're going to be looking at forward, the travel and storage case. Basically, this will help to protect the model when it's not in use, and it's well worth it. It consists of an aluminum case maker profile, and it has plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. Now, the upper section of this case is partially lined with soft foam blocks in different heights, which will, of course, help cushion the model. And it also has 3 internal zipper pockets for storing cables and other accessories. So, for example, if you do order one of these travel cases with your storage model or with your uh, factory model, in most cases, we will ship that with the factory model in the storage case, and any components that would come with the factory model, like the work pieces that are used in the process or any cables or whatever, are usually stored right in those pockets. So I just mentioned that because we sometimes have people contact us and say, "Oh, we couldn't find any cables, or we couldn't find the work pieces." Well, if you receive the storage case, that's because a lot of times they're stored right in there. The lower portion of the case is lined with hard foam, and it's designed so that, as you see there, that once the top of the travel case is removed, you could essentially leave the model in the bottom section of the case and it remains fully functional. Exterior dimensions are approximately 41 by 33 by 17 inches. It has a weight of about 53 pounds. I do want to note one more thing, that even when you're using the travel and storage case, you do want to keep the model upright, and if you're going to be transporting this over distance where you have to have it shipped somewhere, you do always want to ship this flat on a pallet, and that's again just for the protection of the model. Now, moving right along, the next group of models that we're going to look at, as I hinted at before, will focus on the area of IoT. And these are under the umbrella of Training Factory Industry 4.0 models. Now, this group of models was designed to help address how the recent changes in industrial production, which were driven by digitization, have created a need for stronger networking and more relevant information on all production levels. So with this in mind, this version of the Industry 4.0 update of the existing factory simulation model. Because of this, such digitization activities can now be simulated, learned, and applied on a smaller scale before you implement them on a larger scale. Now, as the video that you're going to see here has a really nicely narrated overview of just how the factory works, and it's going to walk you through the entire process, I'm just going to start this off and step back for a moment and allow you to listen to the narrator. So here you go.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The FischerTechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
All right, so just to summarize things really quick, here are some of the topic areas which can be addressed with the FischerTechnik Training Factory Industry 4.0. You can address training and simulation on a realistic production model. You can talk about in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices. You can learn about using and operating dashboards, learn about web-based remote maintenance, limiting of production and materials planning, or linking of production and materials planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. Now, as you just saw, this model incorporates many features not found in the models that we discussed earlier on, perhaps most notably being the use of a cloud-based dashboard for monitoring and controlling the model. Other examples of features found on this model that you haven't seen previously would be the inclusion of a camera for visually monitoring the factory functions from the cloud-based dashboard, as well as an environmental sensor, which will collect data on variables, things like temperature, air quality, humidity, and air pressure. There's also the use of NFC chips in each workpiece, which enables the position of the workpiece in the work cycle to be mapped. Now, in regard to the 24-volt version specifically, I should note that it is also a little bit of a hybrid in that while requiring a PLC for operation and control, it will also incorporate a FischerTechnik Robotics TXT controller. And in this case, the TXT controller serves as the MQTT broker and interface to the FischerTechnik cloud. Now, communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. And of course, OPC UA is also known as OPC Unified Architecture. And this is basically a standard for exchanging data across different platforms such as this. Now, in addition to the TXT controller that's found here, there is also an IoT gateway using Raspberry Pi with Node Red. And this allows the option for not only presenting and using data on the dashboard in the FischerTechnik cloud, but also to be able to display data and calibrate stations of the factory in a Node-RED dashboard that you create yourself. Now, the model also incorporates newly developed 24-volt adapter boards to interface to the PLC, and these, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, this latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM or pulse width modulation, and they also have push-pull output stages for phototransistors and for any buttons. Now, unlike the 24-volt models that we had looked at previously, the new 24-volt Training Factory Industry 4.0 does include access to a sample program. Now, in this case, the sample program is created in structured text or ST format, and it was specifically designed for use with a Siemens S7 1500 PLC. This program is available for download on GitHub, And of course, the new training factory could also be controlled with other PLC models and brands. And for that, all you would have to do, the end user would have to make adjustments to the sample program. And there is also source code available on for download on GitHub as well if you wanted, proceed in that manner. Now, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from our fischertechnik.biz website. And it's also available if you want to just email me. I'll give you information on that at the end. If there's any of the documentation relating to any of these models that you're not finding on our website for whatever reason, it should be up there. But if you don't find it, feel free to email me and I'll be happy to get you whatever you might be looking for. I also will mention that as of last year, there are 2 additional versions of the 24-volt model which are available, and we're going to discuss those just a little bit later in the presentation. Now, in the case of the 9-volt versions of this model, the control is facilitated through the use of 6 robotics TXT controllers. And again, all of the programming with the 9-volt version is preloaded. So essentially, once the connections to the internet and the cloud-based dashboard are made, all of which are again clearly outlined in the downloadable documentation PDF, which accompanies the 9-volt version. So once you do that, you should really be able to get started pretty quickly. The 9-volt version would require the use of 3 power adapters, which of course we would quote you on if you were looking at one of these. And I should also say at this point that even though it goes without stating, when we are talking about whether it be the 9-volt or the 24-volt version, it is also required that, of course, the end user has the ability to access the internet as well as some sort of a tablet or device for accessing the cloud-based dashboard. So do note that you are getting the factory here. You are not getting the the tablet that the gentleman was looking at in the video. That would be something you would provide on your own. Just to finish things up, the dimensions of the model are approximately 39 by 31 by 16 inches. It has a weight of between 51 and 53 pounds, depending on the version. And as with the 2 factory simulation models that we discussed previously, we do recommend the optional travel case to help protect your model during travel and storage. And that's essentially the Training Factory Industry 4.0 model, again, available in both a 9-volt and a 24-volt version. But we do have some other things to talk about, and one of these is a model that was added in 2023, and this model incorporates the cutting-edge technology that is quickly becoming part of our daily lives, and that's AI. So this model is the quality control with AI system model, and it's ideal for visualizing this complex subject area in a hands-on manner as it creates sustainable learning experience by linking theory and practice. Now, processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. So what are we talking about? Well, the fischertechnik sorting line that you see used with this model comes with workpieces in 3 different colors, red, white, and blue, of course. Now, besides that, the workpieces are marked with 3 different processing characteristics, as well as various fault patterns. So the workpieces basically will get scanned by the camera as they pass on the conveyor belt and classified with the aid of the trained AI. Now, depending on the color, the feature, and the fault pattern, the workpieces are then sorted by the artificial intelligence on the basis of their quality features. Now, the AI used is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the fischertechnik's TXT 4.0 controller, and the model sequence control is implemented in the RoboPro coding programming environment as well as in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and in this case, the training is done in Python, for which a sample project is provided for explanation. And that's the new quality control with AI model. It's ideal training, simulation, and demonstration model for education and for research and the visualization of AI systems, machine learning, and neural networks. It's available only in 9-volt at this time. There is a plan for a 24-volt version to be released hopefully at some point in 2025, although you will see something incorporated in another model we're going to look at in just a minute here. I will mention that the 9-volt version uses the fischertechnik robotics TXT controller as you see there, and as before, of course, you're going to need one 120-volt power adapter to use with that. So that's the quality control with AI model. Now, the next thing we're going to look at is the just released Agile Production Simulation model, which is the very latest iteration of the factory models that we looked at earlier in this presentation, but this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI, and this time also with a digital learning platform included as well. Now, this factory of the future is the subject of numerous research projects in science and industry. Forward-thinking companies which rely on automation, modularity, artificial intelligence, and agility to remain competitive now, in order to promote these topics in industry and research, students, apprentices, as well as employees really do require the corresponding know-how and awareness to deal with these complex issues. And this is where the learning concept of agile production simulation comes in. What this does is it simulates processes such as quality assurance using artificial intelligence, similar to what we just looked at. It incorporates the functioning of a driverless transport system and also replicates automated processes on a small scale, from goods receipt to modular production to quality assurance. Now, the accompanying learning materials used with this translate the hands-on simulated processes into future skills for both students and for teachers. Excuse me, for students and for teachers. And the digital twin of this model will significantly intensify the learning process. Now, as we don't yet have a narrated video for this particular model, I'm going to provide you with a quick overview, beginning with the module where the incoming and outgoing goods are placed. And this is, of course, where the material flow of the workpiece begins and ends. Now, in this case, the raw material is delivered at the goods receipt slot, positioned on the color sensor for quality control using the 6-axis, in this case, the 6-axis robot with a vacuum gripper. So 3 more axes than before, and then encoded on the NFC reader. The robot then places the workpiece on the automated guided vehicle, or as we'll refer to it, the AGV, for further transport around the factory. Now, the module also contains the central control unit, which in this case is a Raspberry Pi, and the environmental sensor, which will measure the different environmental conditions in the factory. Things like humidity and air pressure and so on, as we talked about before. Now, there's also an integrated movable camera, which can be swiveled in 2 axes to provide an insight into the entire factory via the fischertechnik cloud-based dashboard, which we saw examples of again in our previous video. Now, at the end of a cycle, a finished workpiece is delivered at the goods dispatch by the AGV. So this is where it begins, and this is where a workpiece also comes back to. The next step for a workpiece after goods receipt is usually the high bay warehouse. Although, because this is an agile production simulation, this could differ if there was a need for doing so. But in any case, the high bay warehouse contains 9 slots for workpieces, has a stacker crane, and a vacuum gripper that picks up the workpiece from the AGV at the docking station and hands it over to the stacker crane for storage. Now, the workpiece is again placed in a workpiece carrier tray, as you saw with previous models, and retrieval of the workpieces is done according to the first in, first out principle. Now, what I will mention again is this is, if you're seeing this and you're saying, of course, it's similar to the previous versions of the high bay warehouse that you saw, keep in mind that with the modules on this agile production simulation model, that there is a crane, there is a gripper arm on each of these modules to help remove the piece from that AGV, the automated guided vehicle that goes around to the different stations, that removes the pieces, work pieces, and puts them back onto the vehicle when the processing is done. So that's a variation you'll see from the other models. Now, next up could be the drilling station, which consists of a docking station for the AGV. Again, a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the drilling head. Now, after the simulated drilling process is finished, the workpiece is again transported back to the gripper on the conveyor belt, and the gripper then places it back onto the AGV. Next up could be the milling station. This consists of a docking station for the AGV, and again, a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the milling machine. There, the milling of two pockets is simulated on the workpiece. And after the process is done, the workpiece is placed back onto the conveyor belt and transported back to the gripper. And again, the gripper moves the piece back onto the automated guided vehicle. Now, in the quality assurance module, in the quality assurance module, a vacuum gripper places the workpiece on a conveyor belt and it is transported underneath the camera and it gets scanned, as similar to what we saw in the previous model. The workpieces, which come in three different colors, again, red, white, and blue, with three machining features, drilling, milling, or drilling and milling, as well as various fault patterns. Again, similar to what we looked at before. And these workpieces are classified using the trained AI. Now, depending on the color, the feature, and the fault pattern that are included on the workpieces are then either placed back onto the AGV as okay, acceptable goods, or they're sent to a reject container as not okay or defective. Now, the AGV itself. The AGV is what's used to transport the workpieces from one workstation to another. It's a track-bound vehicle that follows the printed black tracks that you see on the floor of this factory model. It uses ultrasonic sensors to detect objects that might be in its way. The vehicle has omni wheels, which because of that, it allows it to move in all directions. Two buttons and a photo transistor help the vehicle dock to individual factory modules, and the AGV receives its driving commands from the central control unit, the industrial standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power source. Now, when the battery of the AGV runs low, the AGV will navigate towards the charging dock, where it is automatically charged with a charging unit with charge monitoring. Contacts on the bottom of the charging station connect with the AGV and the charging electronics. And then you have some of the specifications for this. So you basically have a 24-volt power supply, 11 amps. Central control is by the Raspberry Pi 4B. Individual modules are controlled via 5 SPS Siemens S7 1200 PLCs, each of which is included with the model. So this will come with those PLCs included. There are also three fischertechnik Robotics 4.0 TXT controllers that are used on there for sensors, for camera, for cloud access in the WEA module for quality assurance with AI, and for the automated guided vehicle. And there's also a WLAN router for the WLAN network as well. Some of the software you have here, you have SPS programs in structured text format, TypeScript for central control of the Raspberry Pi. You have Node-RED for communication between the SPS and the TXT 4.0 controller, and TensorFlow for supervised learning and quality assurance with AI. And there is also a digital learning platform with a digital twin of the APS model. And because of this, learning can be done with both the actual model as well as in a virtual environment. Now, we hope to have more details on this shortly, as well as other aspects of the new model in a new video we will be releasing. But essentially, this digital twin will ship as part of the APS model. So when you get the APS model, you do get that digital twin as well. So, that's the whole package. So at this point, let's discuss how much do these models cost. Probably a good time to get into that. First off, we're going to start off with conveyor belt, the basic 24-volt conveyor belt, which requires the PLC. You're looking at $359.95 each. The 9-volt version, which would include the PLC, or excuse me, the TXT controller, which would come pre-programmed in the case of the 9-volt, that is $518.95. The punching machine with conveyor belt, the 24-volt version, is $464.95. Again, will require PLC and programming. A 9-volt version pre-programmed with the TXT controllers, $599.95. Indexed line with two machining stations, 24-volt version is $1,199.95. Again, PLC and programming are required. 9-volt version, which has two robotics TXT controllers pre-programmed, is $1,394.95. And again, with these 9-volt versions, you will need a power adapter. In this case, two power adapters because there are two TXT controllers on it. The 3D or 3-axis robot in the 24-volt version, $1,094.95, requires PLC and programming. 9-volt version with the TXT is $1,369.95. Moving on up to the vacuum gripper robot, only available in a 24-volt version. You are looking at $1,199.95. Automated high bay warehouse, 24-volt version, $1,448.95. 9-volt version with the TXT, pre-programmed. The 9-volt is $1,318.95. The multi-processing station with the oven, the 24-volt version, you're looking at $1,287.95. The 9-volt version is $1,474.95. The sorting line with color detection in the 24-volt version, $1,126.95. The 9-volt version is $1,128.95. The factory simulation. The basic factory simulation, as per what I'm checking here, is currently only available in a 24-volt version. As you will see, it is $5,299.95. And of course, this is the non-IoT version. This is just the factory that operates off of the PLC itself and the programming. So there's no cloud connection. There's no dashboard with this version. On the other hand, the Training Factory Industry 4.0, this is the version where the factory itself is controlled and monitored from that cloud-based dashboard and also the Node-RED dashboard if you choose to go in that direction. The 24-volt version is $9,659.95. It does come with the sample program and ST format. The 9-volt version with the pre-wired robotics TXT controllers is also $9,659.95. But wait, there's more, as they say. There is a new variation of the Training Factory Industry 4.0 24-volt, which also includes, because normally any of these training models will be the model itself. As I mentioned before, you need the controller, the PLC, I should say. You need to provide your programming. But also, of course, there is additional wiring that has to happen from the model to the PLC connection board, etc. This version of the model will include the PLC connection board. So you've got your cabling, as you see there. You've got all that stuff so that basically this is giving you more of what you need aside from the PLC itself. So no PLC with this, but you do have the wiring, the connection board, you've got the power supply. This version is $12,879.95. Next up, if you do want the PLC, there is a version that ships with the Siemens S7 1500 PLC. So you've got all of your wiring, you've got your connection board, you've got your model, you've got your programming, you've got everything essentially there. What you were looking at here is a cost of $19,639.95 for educational institutions. For commercial users, you're looking at a cost of $20,124.95. So just to go over to capsulize the Training Factory Industry 4.0 versions, the basic 24-volt version with the PLC connector board is $12,879.95. The version with the Siemens PLC S7 1500, either $19,639.95 for the educational version, $20,124.95 for the commercial version. Now, other items we touched on, the power adapters that I talk about for use with the 9-volt versions, they are $12.99 each, so very affordable. The travel and storage case, which can be used for the factory simulation and Training Factory Industry 4.0 models that we just looked at, the travel case, which can be used for those, is $1,524.95. The quality control with AI model that we looked at, the 9-volt version, only a 9-volt version right now, of course, pre-programmed with the TXT controller, is $2,249.95. No 24-volt version currently, but we're hoping. Meanwhile, the Agile Production Simulation. This is a 24-volt version only. It does ship with 5 Siemens S7 1200 PLCs and 3 TXT 4.0 controllers, plus includes the digital twin, such as you see on the computer screen over there. The cost for this is $28,174.95. And there is a storage case for the Agile production simulation. It is $4,024.95. As you see, comes in basically two main sections where each of the components, basically the substations of the APS model each have a little resting place in there. As you see, there are little notches on the floor so that basically it's like a little puzzle piece that kind of snaps together. And there's also some optional models that can be added on to the factory as well. So we will get into that in the future here. Anyway, at this point, if you have any questions, I would ask you to use the chat window or the question windows, which are found on the Zoom toolbar. If I don't see anything come up, because I know we've been running a little long, I will move right along to taking the next step. So if you would like to request a full color brochure and obtain current pricing, if you would like to ask any questions of any of us directly, if you'd like to ask questions of me, if you'd like to request a quote or speak with your dedicated educational representative, depending on which state you're in, just call us here. Our number toll free is 888-561-7521. You can email general questions, quote requests, things of this nature to info at studica.com. If you do have any questions for me specifically, anything you would like me to provide, answer any questions about either the fischertechnik models we looked at today, something we haven't looked at yet, pricing, any kind of fischertechnik related questions you might have, you can email me directly, lance.zurich, lance.zurek @studica.com. So on that note, thank you very much for taking the time to attend today's presentation. Have a great day. We look forward to hearing from you soon.